Action.
Okay, for my first lesson, I want the students to see how infectious disease can spread through a class. And this lesson is titled Infectious Disease Simulation, oddly enough. And it's designed for anywhere between 6 through 12 health class. And the reason I chose to run a simulation for this lesson is that it'll get the students up and moving around, and they will be able to actually visually see how an infectious disease could run through a classroom setting and through a school setting, and it's very easy. So the student objectives for this lesson is that students will be able to identify how an infectious disease can spread from person to person, and students will have a better understanding of what some of the steps that they can take are to prevent against an infectious disease. So, like I said before, it's going to be a simulation, and the simulation is going to use two chemicals that should be able to be found definitely in a high school chemistry or even any science lab, and more likely than not in an in a middle school lab as well. If the chemicals are not available, and the chemicals are phenolphthalein and sodium hydroxide, if they're not available, you can do the same lesson and the same exact simulation using red cabbage extract, which is very simple to do. I'm not going to waste time explaining it. Red cabbage extract and baking soda. So right now I'm going to shift gears a little bit, and I'm going to actually go into the lesson how I would teach it. So, good morning, class. What we're going to be doing today is we're going to be running a little simulation. And this simulation is designed so you guys can see how an infectious disease can spread between people. How this is going to work is all you guys are going to get a test tube. And that test tube is going to be about halfway filled with water. And you're going to walk around and you're going to mix up the water with other test tubes. The kicker is that one of those test tubes to start has a chemical in it that will react when I add another chemical to it, and that test tube will change pink. Will turn colors to pink. So, how this is going to work is you're all going to get your test tube, and there's going to be 4 rounds. And you're all going to walk around the classroom randomly, and when I say stop, whoever's closest to you, you're going to walk up to them, and you are going to grab test tubes, and you're going to dump the water completely into one test tube, completely into the other test tube, and then split it so it's about 50-50 again. Once everybody has done that, I'll say start, and you'll walk around the classroom randomly again. And then I'll say stop, and you'll do the same simulation. Once the simulation is over, I'll walk around with a dropper, and I'll drop a couple drops of a chemical into your test tube. And if it turns pink, that means that you got infected. And if it stays clear, then you weren't infected. The point of the simulation is so you guys can have a first-hand experience and be able to first-hand see how an infectious disease can spread through a community, especially a community that works very closely together like a school. So first things first, before we run the simulation, now that you guys know what we're going to do, I'd like to hear some predictions. So if you guys could all grab out a pencil and paper, and please write down what you think the percentage of classmates are going to be infected. So do you think it's going to be 30%, 20%? Remember, we're doing 4 rounds. 30%, 20%, 100%, 80%. Write the percentage of what you think the students are going to be infected, and write why. So just give a little rationale. Switch back. The reason I have the students write down what they think and why is because they're able to collect their thoughts on paper, because then I'm going to ask them to share what they think and why. And I don't want to put any student on the spot. I want them to be prepared if I call on them. So that's the rationale behind having them write it down. Okay, class, if you could share what you wrote down. Jordan, what was your prediction?
75.
And why?
Because it spreads easily, and we come in contact with a lot of different things that can spread it.
Okay. Jimmy?
Well, I kind of did mathematically. If we have, let's say, 30 people in a class and I'm getting in contact with 4 other people, I'd say it's a little above 15% or right around there.
15%?
Yeah.
Okay. Darby?
I'm going to go higher. I'm going to go higher than both of them, actually. I'm going to say 90% because I feel like just 4 times around with all the different people, it's going to get spread quicker.
Okay.
Then.
And Jimmy and Darby, you guys were pretty big in discrepancies there. Is there any reason why either one of you think?
Well, now that I take into effect that other people are going to other people too, so you're not only getting that person's, but you're additionally getting the people that they got too. I'm going to have to say that it's going to be a very high number.
So you're gonna.
I'm going to change mine to
completely change
a very high majority number.
Okay, so do you have a number in mind?
85%.
85%. All right. So now this is a time where I'd actually have the students run the experiment. And they'd all be walking around and exchanging test tubes with everybody. And the beautiful thing about this, obviously, is when you exchange the test tubes, everything remains clear. So by the end of the simulation, the students have no idea whether or not they're infected, and they also have no idea who was Agent Zero or the first person that was originally infected. And actually, they'll have no way of figuring that out. You can only narrow it down to the first 2 people. So the students run the simulation, and then we come back. I have already walked around the class at this point and added in the droplets of water. So the infected students have now turned pink. And the simulation should yield somewhere between at least 80% and probably between 80 and 90, with 90 being the more realistic number. 90, very close to 90, if not even higher. I've actually run this simulation before, and there were 4 people in the class that ended up not being infected. So the number is going to be very high, and I would like the students to be surprised with the results of the simulation. So now we're going to switch back, and I'm going to go back into class mode. So now that you guys have run the simulation, you can see that the vast majority of the class is infected. Are you surprised? Are you guys surprised with what happened? Do you have any feedback on it? Let's hear what you guys think.
I'm not surprised at all once you really think about it and you think about you're switching waters with somebody and they've already switched with maybe 3 other people or 4 other people themselves. It really feels like the whole class is going to get connected at the end.
Okay. Anybody else? No? Okay. Well, that's fine. What about this? How can people in a community come in contact with things that a ton of other people come in contact with? Like what Jimmy said, you've already switched waters with somebody else, and that person has already switched waters with somebody else. What are some things that may carry a lot of germs that other people come in contact with on a regular basis with how infectious disease could spread? Like, what are some thoughts on that? Jordan?
Doorknobs, toilet seats.
Doorknobs, toilet seats, Jimmy?
I think something that's very relevant for Minnesotans is when it's winter out and we're inside all day, I think we're all in that same air that may not be circulated as well. When you're outside, you don't really spread germs if you're breathing as much. So inside, maybe that has a factor with the air.
Okay. Darby?
I also think that, everyone goes to the bathroom, and then if you go to shake someone's hand or something, you could transfer it like that as well, if you don't wash your hands and aren't hygienic.
Okay. So, as we can see, there are actually a lot of ways that infectious diseases could be spread. So, what I'd like you guys to do now is on that same original sheet of paper that you guys had before where you did your predictions, if you could take that piece of paper back out, and I would like you to write what the actual class percent was. We would have done the math and factored in what the class percent would have been. So compare your prediction to the actual class percent. Discuss why, like you guys just did, discuss why you think that prediction was like that. And then possibly write some steps down about how you could prevent this from happening in an actual community situation. Because obviously in this simulation, if you were going to get infected, you were going to get infected, and there's no way to stop it. But when we actually get out in the community and we're trying to lead a healthy lifestyle and we get out there are ways that you can prevent the spread of infection. So if you guys could take the time and write on that, please. So for the sake of this lesson, this would be my wrap-up activity. This is what I'd have the students do, and this could be like kind of an exit card for them. So this would be the wrap-up activity. They'd write down this. It would give them a chance to reflect back on the simulation. And then when all this writing was completed, I'd get a little bit of student feedback about how the lesson went before they left. So Guys, anybody can answer this. You don't need to raise your hand. You can be informal. What did you guys think? What did you guys think of the simulation that was run today?
Thought it was real interesting. It's funny to see how people you're interacting with people you don't even know about. Like you're interacting directly with one person, but that person also did it with 3 other people you might not even know about. So I thought that was cool.
I'd have to agree.
I agree with Jimmy as well.
And so then I'd collect their paper, and that would be what I would use to assess this assignment. I would either, probably more likely than not, just grade on whether or not they address the topics and give them 5 to 10 points, depending on what my scale is. So that's that lesson.